Hey, welcome back. Guys, this is lesson number 5 in the real numbers course, and it's a biggie because today we're going to discuss fractions. Let's get right to work. In our previous 2 lessons, we continued our exploration of the real numbers by laying out the integers. Okay? There they are. You see them on the number line there. Well, it turns out that knowing about the integers is really going to give us a structure where we can fully understand the true nature of the real numbers. In fact, tell you what, let me just get right to the point. Here's the definition of the real numbers that we'll work with. The real numbers are the integers and all the numbers in between. So let's go back to our picture here. We've got our integers. Now we need to look in between them. And it turns out that's where all the action is. That's the show. There are way many more numbers in between the integers than we actually have integers. So let's dive in. Let's go get some of those numbers in between. And the first group we're going to look at are the fractions. Right off the bat, let me just tell you, this is a huge fact. This is really important. Fractions are numbers. They're numbers. Fractions are numbers. Just like the whole numbers, just like the integers. Fractions are numbers. Now, they've got a special job. They're the numbers that help us understand parts of things, but they're numbers nonetheless. So, for example, going with this parts of things idea, if you take a thing and break it up into 2 equal pieces, then we call those pieces halves. If you break it up into 3 equal pieces, then the pieces are called thirds. And if you break it up into 4 equal pieces, then the pieces are called fourths, etc., etc., etc. Okay? So it's about breaking them up into those equal pieces. Now, what's really going to help us understand these is maybe to get a visual of fractions when we're talking about fractions. Just like, when you first learn the number 2. Like, in fact, let's go back. If you had to represent 2 using number bars, using some bars, so we can think of them as candy bars, let's say. It must be close to snack time, thinking about candy bars. Well, let's say you had a bunch of candy bars laying on the table and you wanted to show somebody, you wanted to represent the number 2 to them. Well, what would you do? Yeah, of course, you would just grab those 2 bars and show them. Say, hey, here are those 2 bars. Well, I can't do that on the computer screen, but here, I'm just going to take 2 of those bars. I'm going to shade them in, and that's what I mean by 2. I don't need that 3rd bar. 2. All right? Well, what if we wanted to represent 2/3 using those candy bars, those number bars? Well, right off the bat, I want you to understand something really important. I only need 1 bar. 2/3 is less than 1. So let me get rid of those other 2 bars. I don't need them. Let's just stick with that 1 candy bar. We're talking thirds, so that means I need to break it up into 3 equal pieces. Let me do that. I'll do my best here. So 3 equal pieces. And how many do I need to shade? Well, that's what the numerator tells me, the top number. 2. I need 2 of those thirds. So let me just shade them in. 1/3 and 2/3. There it is. So there's a representation of the number 2/3. Looking good? All right. Well, let's try another one. Let's do 7/10. Get out of there, bars. I told you 2 bars. Get out of here. I told you I don't need you. Just the 1. Good. Take that bar. What do we need to do? Well, we need to break it into 10 equal pieces. Now that's hard, okay? So do your best drawing it by hand. I'm going to cheat a little bit. I'm going to use the computer to help me draw it, but just take your time. 10 equal pieces, right? We're talking tenths. 3, 4, 5, 6, 7, 8, 9, 10. There it is. And how many do I need to shade to represent 7/10? You got it. 7. 7 of them. 3, 4, 5, 6, 7. There is 7/10. Nice job. Okay. What about this? What if you had to represent this fraction? 37/48. Well, and I just told you a second ago, doing 10 equal pieces is really hard. 48 equal pieces, whew, forget about it. Okay, you're going to need to get some technology in the game or some drafting tools or something. So for us, we came up with another way to do this where you don't have to do all those pieces, draw all the pieces. It's called benchmarking. Let me show you how it works. If you were to do all 48 equal pieces, show all those lines, well, when you got to the end, that's where the 48th piece would end up, right? That's the 48th piece, the end. Well, as you went through and you got halfway through the bar, half of 48, that piece right there, that's where the 24th piece ends. We're just cutting it in half. Those are the benchmarks. The whole thing, halfway, that would be where the 24th piece ends. Now, I'm not quite in the area I need to be in. Look at that numerator. It's 37. Well, okay, definitely it's going to be somewhere between the 24th piece and the 48th piece, right? Let me cut it in half one more time, give you another benchmark. Right there. What piece would that be? Good, I heard that. Who is that in the back? Nice, it's the 12th piece. 12th piece, good work. All right, now 12, and then another 12 pieces will get you to 24. 12 more onto that. That's where the 36th piece would be. See, we're not drawing all the pieces in between, just the important benchmarks. Okay, well, this is good news because if I know where the 36th piece is, the 37th piece should be just to the right. And I'm going to mark that with that pink line. All right, that's where the 37th piece would be. So let me shade all the way up to that piece. And there's a good representation of 37/48. Okay, it gives us a way to estimate this without drawing all those lines. Looking okay? All right, that brings me to the second huge fact of the day. We got a lot going on here. This is part 2. There's a special kind of fraction. I know you guys have heard of this before. Percent just simply means hundredth. Percent is just another way of saying hundredth. So if you wanted to represent the number 23%, all you need to know to use what we've just developed here is that 23% is just another way of saying 23 hundredths. So let's represent it. There's our number bar. Oh, hundredths. Okay, we're not writing all those pieces. Benchmarking time, right? Benchmarking time. So the very far right end, that's going to be where the 100th piece ends. Let's cut it in half again. Draw that line. That's where the 50th piece would end. Cut it in half again. That's where the 25th piece would be. Good. And look at that. We're right in the neighborhood of where we need to be because we want 23 hundredths. So just to the left of 25, that's where, if we draw in that line, that's where the 23rd piece would be. So let's shade up to that. There's a good representation of 23%. Looking okay? All right. You also want to be able to go backwards with this. I've been giving you fractions and we've been writing down the fraction bars. But let's say someone gives you a bar and asks you to come up with the number that it's representing. Like, for example, this one. So if you wanted to give the number that this fraction bar, this candy bar is representing, I'll tell you what, there'd be lots of possible answers, lots of correct answers. This is asking for an approximation, okay? And there's lots of fractions out there. So let me help us a little bit. Let's say we want to know how many fifths we see there. So what that means is we should take this fraction bar and see how many fifths. Let's divide the whole bar into fifths, and we'll see if we can measure where that shaded, that in this case the black shading ends. Well, I'm going to try to do 5 equal pieces here. I'll do my best. 1, 2, 3, 4, 5. Okay? Just drew in those 5 equal pieces. 3, 4, 5. Hey, and that's pretty good. It looks like to me that we're almost shaded up. We're in fact right at the 3/5 mark. Okay, so I'm gonna fill in that as 3/5. Okay, it's always a little bit harder to go backwards, but if you work at it, you'll get it. All right. In the real world, this comes up all the time. Okay, let's say you had a gallon jug, and for some reason you needed to fill it with 5/7 gallons of water. Well, this is just like our candy bar, right? Except now we've got a container, and we've got to figure out where 5/7 would be if you fill it up. Well, we know what to do. 5/7. So first of all, the sevens. Let's break it up into 7 equal pieces. Again, I'm going to cheat a little bit. I'm going to use the computer to help me. Let's do 7 equal pieces. 3, 4, 5, 6, 7. Okay, 7 equal pieces. And where do we need to fill up to? Right, the 5th line. Okay, so let's pour water in. Paid my mom a lot of money for special effects. So check this out. We're gonna pour this in. Nice job, Mom. Looks like it was maybe frozen. Okay, but there it is. All joking aside, 5/7 up, filled with water, looking good. This is very much like what a measuring cup has. A measuring cup is a cup with those fractions, those important fractions marked off. All right, you got this. You got this. Here's another real world kind of application. Let's say you've got a map, and it shows this 1 mile long path from start to finish. And let's say your friend is waiting for you 7/8 miles from the start. Let's try to figure out where she is on the map. Okay, we'll mark. She tells you I am 7/8 of a mile from the start. Let's figure out on the map where that would be about. So what that means is, since we want 7/8, we need to take that path and split it up into 8 equal pieces, right? Eighths. Here's a cool way to do eighths. If I cut the mile path right in half, I get two equal pieces, halves, right? If I cut each of those halves in half, now we've got 4 equal pieces, and let's just do it one more time. Cut that one in half, that one in half, that one in half, and lastly, let's check it. Do we have eighths? 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. Beautiful. We're in great shape. And now we just need to put an X at the 7/8 mile mark. Boom, right there. Looking okay? Excellent, excellent job. All right. Here, let's twist it around. Let's go the other way. Same path, same map. This time on the map, there's a point indicated with that green mark there. That's where the bathroom is. And let's try to figure out approximately how many miles from the start that bathroom is. All right. Well, this is like the fraction bar from before. They're not giving us fifths. They're not saying how many fifths of a mile is the bathroom away from the start. So let's just use our own ideas. I want you to notice something. Take a look at this. If that distance right there, if I made another one of them, it would put us about there, wouldn't it? And then one more of them puts us right at the finish. So in fact, doesn't this look like that maybe if we divided that mile path up into 3 equal pieces, doesn't it look like that bathroom is almost right at the first of the thirds that we have there? Yeah, I think we're in business. This right here is 1/3 mile. That's how far away that bathroom is from the start. Looking okay? All right, excellent. Guys, this was really brief and we did a whole lot here. Fractions are super important. So much so that we're going to spend some time here. We need to really understand the numbers in between. So when we get back, we will continue to explore fractions. All right? I know this was fast and furious, but I hope you enjoyed it half as much as I did. I'll see you in the next one. Take care, guys.